So good morning everyone. My name is Umang Goswami and I work as an educator on Unacademy. So today our topic for discussion will be drawing, and you can follow my courses. For that you will have to download the Unacademy learning app, and do subscribe to the YouTube channel of Unacademy and share these lessons. Thank you. So good morning everyone, and welcome to lesson number 64 of mass transfer in the chemical engineering discipline. So in the last 4 to 5 lectures we discussed some problems on drawing, and today also we'll discuss a problem. So this problem was basically asked in the GATE 2014 examination, and this will be the last lesson of the topic drawing, and from next class onwards we'll be starting with liquid extraction. So as we have already seen, for drawing we first studied the mass transfer part, we also studied the thermodynamics of drawing, then we came to the heat transfer aspect of drawing, and then we switched on to some numerical problems. So the question reads as: a wet solid of 100 kg is dried from a moisture content of 80 weight% to 40 weight%. Actually this is a printing mistake, so it's not 80 weight%, it is 40 weight%. So whenever you solve it, just correct it. This is not 80 weight%, this is 40 weight%. Okay, even though if it would have been 80 weight%, then also there wouldn't have been any change in the procedure how to solve the numerical, but the numerical values would have differed. So here in this case it is 40 weight% to 10 weight%. The critical moisture content is 15 weight% and the equilibrium moisture content is negligible. So they have neglected the equilibrium moisture content. All moisture contents are on dry basis. The falling rate is considered to be linear, and it takes 5 hours to dry the material in the constant rate period. So the duration in hour of the falling rate period is. Okay, so it's a simple question. You are given with the time in the constant rate period, and you just have to find out the time in the falling rate period. So SS is equals to 100 kg, x1 is equals to 0.4, x2 is equals to 0.1, and xc is equals to 0.15. These values are already given. Theta c is equals to 5 hours. So when you put it, you get 5 is equals to 100 by A dot nc, 0.4 minus 0.15. So A dot nc you get 20 into 0.4 minus 0.15, and therefore A dot nc is equals to 5. Now theta f is equals to ss by A dot nc into xc minus x star ln xc minus x star upon x2 minus x star. So theta f you have 100 upon 5 into equilibrium moisture content is considered here to be negligible, so we have neglected that, so it becomes 0.15 into ln 0.15 upon 0.1. So when you further solve it, you get theta f is equals to 1.216 hours. So in this problem the main thing was it is not 80 weight%, it is 40 weight%, okay, to 10 weight%. So what all things were given to us were the initial moisture content, the final moisture content, the critical moisture content. Here we also observed that the value of final moisture content is less than critical moisture content, so we had to go till the falling rate period. And it also said that the falling rate period is linear. So as you can see that in the GATE examination each and every question will be very well defined. So you need not worry whether a data is given or not, whether they have asked for this or not. Each and everything will be properly defined. Only the thing is you just need to remember the formulae, and that too formulas which I tell you to learn. So just learn them and try to apply in a particular numerical. So we first found out the A dot nc part, and then we went to the falling rate period. So in the next lecture we will be starting with liquid extraction. Till then, thank you.